Hey guys, so this is going to be the lecture video for College Algebra, Chapter 1, Section 1, which is titled The Introduction to Graphing. So hopefully nothing in this section is new to you if you are in college algebra, and hopefully it's just a nice review about the Cartesian coordinate system, how we plot points, how we graph lines, intercepts, circles, that kind of stuff. There's going to be a couple different formulas and that kind of thing as we move through this and some terminology. But again, hopefully none of it is new to you. You should have all experienced this in either your high school math classes or if you took Math 20 or 30 here at Missouri Southern, you should also have encountered it there. The way this is going to work is I have my notes screen shared with you so that you can see them. These are what I'm lecturing from. You also have access to these on the My Math Lab site itself. You can go and open them up on your own. You can print them off. You can download them. You can use them to highlight with or whatever you would like to do with those. They're there to be a tool for you. So you do have those. The other way I'm going to do it is as we go through this and there's stuff to be like worked through or to be shown, I will show you that on the board. There's some lighting, you can see the reflections of the ceiling lights. If I turn it all the way off, then you can't see the board. So this is kind of the best we can do. So hopefully it's pretty good. I thought it was a pretty good little setup right here. So anyways, let's just jump right into the introduction of graphing. So like I mentioned, this is the Cartesian coordinate system. That's the graphing system that we use in order to graph our lines and our parabolas and our polynomials and our functions and all that kind of stuff. We use this Cartesian coordinate system, which is a plane that is bisected into 4 quadrants by 2 different axes. So each of the lines, you can see it here on the plane one, but I also have a more detailed one in the notes right there in front of you. We cut this board basically into 4 different quadrants using these 2 different lines. We have the vertical line, which is your y-axis, and you have your horizontal line, which is your x-axis. And both of those are labeled on the notes right there as well. Where they intersect here in the middle is the point 0, 0. We call that the origin. And so that's like where we kind of think about like our starting point. It's the middle. And then, like I said, whenever we draw our axes, it cuts this plane or this board or that paper into 4 different sections. You can see that there's all these different sections. And in math, the way that we label those is we label them using the Roman numerals. So we start in the upper right-hand quadrant. We call it a quadrant. Quad means 4. So there's 4 different sections. So there's 4 different quadrants. And we start up here in the upper right-hand quadrant, and we label that 1. And then here's where it goes a little bit counterintuitive. We're going to go counterclockwise in our labeling. So if this is 1, then 2 is going to be over here in the upper left-hand quadrant. 3 is in the bottom left, and 4 is in the bottom right. Those are just ways for us to talk about what a graph is doing in a specific spot of the plane using the same terminology. So if I say that it's going to go up in quadrant 1, then you know that it's going to go up over here. And so that's why we give these different labels and distinctions when it comes to our graph. The other thing that is nice to note is that every point on this plane, now that we've cut it with a y-axis and an x-axis, is going to have both a x coordinate and a y coordinate. And we call those together that make up a certain point an ordered pair. And you can see that in the notes that we label ordered pairs using parentheses, and you have your x value first and then your y value second. If it gets confusing to you on whether or not you're going to label your y value first or second, they're in alphabetical order. So x comes first in the alphabet, your x coordinate comes first when you're talking about your ordered pairs. And there's also a nice thing with these ordered pairs in that the different quadrants have different positive and negative values. Because what our axis actually is, like if you think about our x-axis, if the middle is right here at the origin, then as we move to the right, we have our positive values. And as we move to the left, we have our negative values, because what our axis actually is it's a number line. And in the middle of our number line is going to be the number 0. And then we'll have 1, 2, 3, 4, 5, and so on and so forth. But these are getting progressively more positive. They're positive and they get larger. And then 0's in the middle. And then as we move to the left, we have our negative numbers. -1, -2, -3, so on and so forth. So they get more negative as we move to the left. That's on our x-axis. And on our y-axis, it works the same way, only we're going vertically instead of horizontally. Again, right here in the middle is our origin, that's 0. But then as you move up, you get your positive y values. So you're going to have +1, 2, 3, 4, and so on. And as you move down on your y-axis from the origin, you'll have your negatives, -1, -2, -3, and so on. And so if I'm talking about an ordered pair then that lies here in quadrant 1, well, notice that's on the positive side of my x-axis and it's on the positive side of my y-axis. So every ordered pair in quadrant 1 is going to be positive, positive. So if you look on my notes right there, underneath the Roman numeral 1, that's what that parenthesis means. Parenthesis positive, positive means both the x value and the y value in that quadrant are going to have a positive value. And so if you're given an ordered pair and you see that they're both positive, immediately you should know that it's going to be plotted here in quadrant 1. And so that's a nice little cheat or helpful hint that you can learn how to graph your points quicker. Again, hopefully you know how to graph points. You should at this point. But in case nobody ever pointed that out to you before, that is something that's nice. So positive, positive in the upper right-hand quadrant 1. Then over here in quadrant 2, our x's are going to be negative, but our y's are positive. And so we have a negative, positive for our ordered pair. If we move down to quadrant 3, we have negative x's and negative y's. So it'll be a negative, negative with our ordered pair. And then last but not least, quadrant 4, we have our positive x's and our negative y's. So it'll be positive, negative with our ordered pairs. So again, hopefully all of that is review. And now we're going to actually plot some points. I specifically put my camera video right where I did because I didn't want you to see all of the answers. So I'm trying to cover up the graph that's actually in my notes. Obviously, if you open up my notes on your own, you're going to see where all these are graphed anyways. But I'm going to do it on the board as well so you can see it live and see how this process works, because this is something that's going to come up in your homework. It says graph the following points given on the given Cartesian coordinate system. And so it gives you a graph and then you're just going to drop the points. For A, we have -3, 5. So our x is negative and our y is positive. So we know then that we need to be over here in quadrant 2. -3 is negative on the x's. So we go over 1, 2, 3. And then we're going to go up 5. 1, 2, 3, 4, 5. Where that crosses, where the -3 in the x's and the 5 on the y's cross, is where we're going to plot point A. B, we have 4, 3. Those are both positive. That means we'll move to the right 4, and then we're going to move up 3. And that'll be the point B. I want to say on your homework, they don't have you, sometimes they have you plot points, but a lot of times what they'll do is they'll give you the graph with all the points on it, and then you have to give the ordered pairs. When you are asked to give an ordered pair, please be careful that you make sure you have your parentheses around your ordered pair. If you don't, then you don't actually have an ordered pair. What you have is you have a list of numbers, and it will count you wrong. And I will count you wrong on tests for that. So make sure that you use parentheses to indicate that you have an ordered pair. So I'm going to keep going. I'm not going to pause as much on these because hopefully you're tracking with me. For C, we have 3, 4. So we're going to go over 3 and up 4 for point C. For D, we have -4, -2. So both of these are negative, meaning we're in quadrant 3. -4 on the x's, -2 on the y's, like that. For E, we have 3, -4, so that's positive x, but a negative y, so down here in quadrant 4, 3, -4, E. F, we have 0, 4. Now, 0, 4 is a little bit weird because you're like, okay, well, wait, what do I do with my x? It says 0. So you have to ask yourself, if you have to start here, if that's our starting point is the origin, and it says 0 for our x, that means we're not moving left or right at all. We're just staying right here on our y-axis. And that's what point F is going to do. It says 0, 4, so we don't move right or left. We're just going to move up 4. And we plot it right there on the y-axis at 4. We actually call that a y-intercept. We'll have that in just a couple of minutes. But if it point lies directly on the y-axis, it's called the y-intercept. Conversely, if it lies on the x-axis, then it's called an x-intercept. And that's what G does. Notice we have an x value, we have -3, but our y value is 0. So that means we move to the left 3, but then we're not going to go up or down at all. So we lay right here on the x-axis. So there's G. And then H is 0, 0. So we don't move left or right. We don't move up or down. We stay right here at the origin, which is the point 0, 0. And that's how we're going to plot points on the Cartesian coordinate system. So let's see if I can block some of the work here. Some of your other problems are going to say determine if each ordered pair is a solution to a given equation. Because when we have an equation that has an x and a y in it, and both the x and the y only have a power of 1, meaning there's no other exponents involved, then what we have is we have a linear equation. And a linear equation means we're going to have a line. And when we have a line, the only points that lie on that line are solutions to that given equation. So they can give you ordered pairs, and then you have to determine, are those actually solutions to this equation? And the way that we do that is something that I call the plug and chug method. You're going to take your equation, that 2x plus 3y equals 18. We're going to plug in the ordered pair that they give us, and we're going to see if we get out a true statement or a false statement. If it's a true statement, then that means it is a solution, and that point would actually lie on the line if we graphed our line. If we get a false statement, then that means that that point would not lie on the line at all. So here's how this works. We had 2x plus 3y equals 18. And the first ordered pair is -5, 7. Now remember, an ordered pair is an x and a y value. Your x value is -5 and your y value is a +7. So what we're going to do is we're going to substitute those values into the equation and see if we get a true or false statement. So instead of writing 2x, I'm going to write 2, and then it's times, well, what's the x value? In this ordered pair, it's -5. So I have 2 times -5 plus 3 times my y. My y value is 7. And then equals 18. So then I say 2 times -5 is -10, 3 times 7 is 21, equals 18, -10 plus 21 is 11 equals 18. Is that true? No. 11 doesn't equal 18. This is a false statement. Since we got a false statement, that means that this is not a solution. If we were to graph this line, -5, 7 would not lie on that line. So let's test out our other point. Let's see if I can slide this down at all. Yeah, I got a little bit of space. Slide it down and we'll test out our second point. Our second point was 3, 4. So we're going to do the exact same process, except our x value now is 3 and our y value is 4. Okay, so we have 2 times x, which is 3, plus 3 times y, which was 4, equals 18. Making sure all that's in there. 2 times 3 is 6, plus 3 times 4 is 12, equals 18. We get 18 equals 18. Yay. We just verified that the 0.34 does in fact lie on this original line, this 2x plus 3y equals 18. So that one is a solution because we got a true statement. And that's how we verify those. All right, let's scroll up. Here's a couple of definitions, which we actually already mentioned when we were graphing just a few minutes ago. I mentioned that if you cross the x-axis, if you're on it, like if that point lies on it, like point F did, point F. Wow, my notes are wrong. I need to change those. Okay, so my notes are wrong. My graph on here was right. Let me scroll back over here. So when I graphed it, notice I went up 4 because I actually did graph it correctly there. In my notes though, if you look, I graphed that wrong. I put F over here. I flip-flopped it. I flip-flopped my G and my F. Oops, just goes to show you, even us professors make mistakes. So beware of that, that's wrong there. I will get that fixed and maybe get some new notes scanned in, maybe not, because then you can just see that I'm human and I messed up. But up here, it's correct. So F didn't have an X value, it was, F had a 0 in my X's, and it had, yeah. So F is a Y intercept and G is an X intercept. Sorry, the fact that my notes are wrong really bothers me. But they're always going to look like it shows up here in the notes. And that an x-intercept is where the graph crosses the x-axis, so like right here at G, and it's always going to look like x, comma, 0. So G was -3, comma, 0. That's what that ordered pair was, -3, comma, 0. And it always looks like that if it's an x-intercept. The flip of that is your y-intercept, which is this f that's up here, will always look like 0, comma, y. So this was 0, comma, 4, and that's what f was. F is a y-intercept. These are important to know because as we graph our lines, sometimes we're going to need to graph using those x and y intercepts. And so it's good to know what those look like as ordered pairs. And then also just remembering the terminology as we move forward in this class, because it may have been a while since you had a math class. So how do we graph using the intercepts? We are going to do a couple different graphing systems or methods. Sometimes you're going to just be asked to graph and it's not going to specify whether or not to use intercepts or not. Sometimes it says very specifically on your homework or a quiz or a test that you have to use the x and y intercept. And if you use any other point to graph your line besides the x and the y intercept, it will count you wrong because you didn't follow the instructions. So when you graph using the x and y intercepts, first you have to find those x and y intercepts. So step 1 is you find your x-intercept. How do you do that? By letting y equal 0. You plug in 0 for your y and you solve for your x, and that will tell you your x-intercept. Then you have to find your y-intercept by letting x equal 0 and solving for y. You plot both of those points and you connect them because all you need to graph a line is 2 different points. So using the x and y intercept actually is a nice way to graph because they're usually relatively simple in terms of algebra and finding them. So let me shift just a little. Trying to figure out which way is best, so I'm out of the way. But I guess you just get to look at the back of my head a lot. So we are going to graph actually the equation we were just working with, the 2x plus 3y equals 18. This is the one that we just verified whether or not two different points actually lied on it. So to find our x-intercept, we're going to let y equal 0, and then we're going to solve for it. So if I let y equal 0, 2x plus 3 times 0 equals 18. Well, 3 times 0 is 0, so it's going to go away, leaving me with 2x equals 18. Divide both sides by 2, and I find that x is 9. So my x-intercept would be 9, 0, because x-intercepts always have x, 0. So I'm going to go ahead and graph that. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 0. There's my x-intercept. So we're halfway graphed, I guess you would say. Let me angle out a little bit so you can see the y-intercept. Y-intercept, we're going to let x equal 0 in this case. So it'll be 2 times 0 plus 3y equals 18. Well, 2 times 0 will give us 0. So we're going to be left with 3y equals 18. Divide both sides by 3. And we are left with y equals 6. So my y-intercept will be 0, positive 6. So I'm going to come over here and go 1, 2, 3, 4, 5, 6. And I'm going to plot that point. Now I've plotted both my x and my y-intercepts, and I can connect them using a line. On my math lab, it's actually really nice. It will go ahead and graph that line automatically because you're using a line tool. And so once you have 2 points, it just connects it. But when you're taking notes, this is how you do it, the old school method. You can see mine a little bit right here. I'll scroll up a little bit. So there's our x-intercept and our y-intercept. Again, if your problem specifies that you need to use the x and the y-intercept, don't use anything else. Don't use any other method to graph with. In general, there's another method that's usually a little bit easier to graph with, at least algebra-wise. There's usually less algebra involved. It's the slope-intercept form. That's the y equals mx plus b, and we will use that a lot. But I know specifically in this section, it will ask you for your x and y intercepts and to use those a lot. So just be aware of that. Now we're going to shift a little bit out of the linear area, kind of. We're still going to use lines, but we're getting ready to talk about circles. And when we talk about circles, we also talk about distance formulas and we talk about midpoint formulas. And so we have to talk about those because those allow us to talk about the diameter and the radius of a circle. Now, the nice thing about circles is that we still graph them in the Cartesian coordinate system. So none of that changes. We're just going to graph circles instead of lines. But like I said, we're going to talk about distance first. So this is your distance formula. This is a very important formula. It's good to memorize. Distance is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Those x1s, x2s, y1s, y2s come from 2 different ordered pairs that they give you. So we're going to see that played out because we're going to do 2 different examples with this. But do note that those just aren't new special numbers or anything like that. Those come from the information that the problem will give you. So let me get my black one. We're going to find the distance between these 2 different points. The first one we're finding the distance between -2, 2 and 3, -6. That is how I make my and sign. If it's weird to you, I'm sorry. The more you see it, the more you'll get used to it. And it's not too bad. So here we're given two different ordered pairs. They ask us to find the distance between those two ordered pairs. So this is where we get those x's and those y's. Because what we have here is we have our first ordered pair. So I'm going to label it x1, y1. And our second ordered pair, I'm going to label x2, y2. Now, here's a question that always gets asked. Does it matter which one is 0.1 and which one is 0.2? It does not. What does matter is that my x1 is with my y1. I can't say, well, my x1 is -2 and my y1 is -6, because then I've made a completely new ordered pair, and that will mess up your problem. If you call 3 -6.1 as in x1, y1, and you call -2, 2, x2, y2, it's not going to change anything else in the problem. It will still work out the same way. If you don't believe me, do it, like pause the video and do it that way and see if you get the same answer that I'm about to get, because you should, as long as you do your algebra correctly. Now, we have our points labeled. We need to find the distance. And so here's something I do recommend. Anytime you are dealing with a formula, whether it's something you know or something you don't know, I recommend writing it down, because then it's just a plug and chug problem. Then you just plug in the values, you compute out the answer, and you're all done. So this is the first time we've really played with distance. So I would write the distance formula down. I would say distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. What this does is every time you write it down, it's going to help it stay in your memory. And then you're not going to have to look it up every time. It's just going to be there and ready to be used. So what I need to do now is I need to plug in the values for these x2, y1, or x2, x1 stuff. So x2, well, that is 3 minus x1. x1 is -2. So you're going to have a negative going on here. Hopefully that's sending off alarm bells in your head, because if you have a negative and a negative right next to each other, you can actually change that into a positive. So it'd be like saying +2 quantity squared. And then you'd have plus, and then my y2 is -6 minus my y1, which is +2. And all of that is quantity squared. I will make a little note right here. This is a little table that is very helpful in terms of what happens when you have two signs that are together. If you have a positive times a positive, you're going to have a positive. So if I take +2 times +2, I get a +4. But if I have a positive times a negative, then I'm going to get a negative. So that's when I take a +2 times a -2 and I get a -4. Or if I have a negative times a positive, I'm also going to get negative. And if I have a negative times a negative, I'm going to get a positive. That's what we had going on here. We had a minus and a minus, which gives us a positive value. This table is super helpful when it comes to solving equations, but then also eliminating those double signs. Those double signs can really get tricky later on, and so it's best if we don't write, because what we could have done is we could have written this as 3 minus a -2 like that, and there's nothing wrong with that. But since we are in college algebra, we shouldn't still be doing that. Or at least if we do this, the very next step should look like 3 plus 2. And so if you need this first step, that's totally fine. Just understand that that's not what I'm going to do. I'm going to say, oh, negative and negative becomes a positive, and I'm going to move on. If you need to write that step down so you understand where that came from, totally okay. Okay, so going back up here, I'm now going to work what's inside of my parentheses. 3 plus 2 is 5. And then I have -6 minus 2 is a -8. 5 squared is 25 plus -8 squared. That is -8 times -8, which is a positive 64. 25 plus 64 would give me the square root of 89. Now, 89 is not a perfect square. It does not contain any perfect squares. So the square root of 89 is actually the distance. If we were doing a word problem or trying to measure something, that wouldn't be very helpful. I wouldn't want to go up to the counter and say, yeah, I need the square root of 89 inches of, copper wire. That doesn't make sense. But this isn't a word problem. This is simply finding the distance between two given ordered pairs. And when that is what we are asked to do, you want to leave it like this. Unless it asks for a decimal in a problem, you never want to give a decimal. Decimals are gross. They're not user-friendly in terms of algebra. They are user-friendly in terms of real life and the word problems and the application problems, and we will do some of those. But to get started, like when we're doing these problems, leave it as the square root of 89. So this whole process right here is how we find the distance between 2 points. Now, since I'm using a whiteboard and I'm going to erase a lot of this, and I'm going to erase my 2 points so that we can do B. B. If at any point during any of my videos, you're like, man, she talks really fast, or I missed that. The nice thing about having a lecture video is that you can pause it while you write down stuff or while you try to work the problem out on your own. And then you can push play when you're ready, or you can listen to me and then you can also rewind it and go back and see if there was something that was confusing or that I lost you on. So for B, we have -1, -5 as our point, and -1, 2 as our second point. So again, I kind of left up the rubric of our last problem in that my first pair is already ordered x1, y1, second one is x2, y2, and I already have my distance formula written down. So now I'm going to plug in those values for the x2, which is -1, minus, and then my x1 value is a -1. So negative and a negative will make this into a positive 1 quantity squared, plus y2, which was 2, minus y1. Again, we have a minus, so it becomes a positive. Well, -1 plus 1 would give me 0. I mean, 0 squared is going to give me 0, but I'm still going to write that in there so that you don't just think something disappeared. And then over here, we have 2 times 5, or excuse me, plus 5, which is 7. So 7 squared is 49. And the square root of 49 is 7. Now, some of you, hopefully, are pausing and saying, well, the square root of 49 is plus or minus 7. And you are correct. Because if I take -7 times -7, I do actually get 49. So when you take the square root, you do typically think about having both a positive and a negative solution. However, this is a distance problem. We don't think about distances in terms of negatives. I'm not going to say I ran -7 miles today. I'm going to say I ran 7 miles today because that makes sense. I don't have a negative distance. And so you just want to give that primary positive square root solution for that. So that's distance, and that's how we use it. The next formula of sorts that you have is something called the midpoint formula. The midpoint formula, again, deals with 2 different ordered pairs. And the way we think about it is that we think about that there's a line segment connecting those 2 ordered pairs. And so we have this line that goes from these 2 spots, and we want to know what is halfway between them. What is the midpoint, and where does that lie? And so that's what our midpoint formula is going to allow us to do. And as you can see right there on your screen, the midpoint formula is an ordered pair. It's a big set of parentheses, and then you have your x value, comma, your y value, because the midpoint is going to give us a specific point on the Cartesian coordinate system. So if you look at that, we have x1 plus x2, all divided by 2, and then y1 plus y2, all divided by 2. And we're going to do an example of this. We're going to find the midpoint of a line segment between 2 points, -4, -2, and 2, 5. And just like with distance, I'm going to write down the midpoint form because I need to learn it so that I don't have to look it up every time I need to use it. To find the midpoint, I take x1 plus x2 and divide it by 2, and I take y1 plus y2 and divide it by 2. That's what I'm going to do. So again, I'm going to label the first one x1, y1. And I'm going to label the second one x2, y2. Do you have to label them every time? No, you don't. I'm not going to come up behind you on a test or a quiz and be like, why don't you label that? However, in the beginning, it is useful because then you're not going to get confused on which x goes with which y and things like that. So for my x1, that is -4, plus my x2, which is 2, all over 2, comma, y1, which is -2, plus y2, which is a +5, all over 2. -4 plus 2 is going to be a -2 over 2. -2 plus 5 will give me a +3 over 2. So I'm left with -2 divided by 2 will give me a -1, comma, 3 over 2. Yes, I know that the number on top in this fraction is larger than the number on bottom. That's okay. It's called an improper fraction. And it's okay to have improper fractions as long as they are simplified, meaning that 3 has nothing in common with 2 except for the number 1. If it had anything in common that we needed to simplify out, we would need to do that. But since nothing, like over here, I didn't leave this as -2 over 2. Why? Because they both shared a 2, and I could divide that out, and then I'm left with -1. And so you always want to simplify, but you wouldn't want to say, well, this is 1.5 and write it as a mixed number, or you wouldn't want to call it 1.5 and write it as a decimal. You'd want to leave it as a simplified fraction. And your homework and quizzes are very good at giving you, I think they're blue. They give you these blue little boxes of instructions right next to your answer box, where it tells you to either give a decimal or give a simplified improper fraction or to round to the nearest hundredths place or whatever like that. Like it tells you exactly the format that it wants so that you don't mess up on that. The one thing to be wary of in terms of midpoint is it is a point. It is an ordered pair, so you do have to make sure you always have those parentheses. So be aware of that. So now that we've done distance and we've done midpoint, let's talk a little bit about circles. I'm probably gonna have to move my box over because circles, there's a little chunk of notes right here. Let's see. I'll just move me slightly off screen for right now. So we're gonna do some circles. Circles has a neat, I think it's a neat definition. It makes sense if you start to think about it. It's the set of all points in a plane equidistant from a center. So a circle is going to have a center point, as you can see in the picture on the screen. And every point that actually lies on that circle is going to be the same distance away, equidistant, same distance away from that center point. That distance is actually called the radius. It's labeled there on our picture, and that's half the length across the circle. So if I was on the circle and I walked to the center of the circle, then I traveled the same distance as the radius. If I walked all the way from one side of the circle through the center, all the way to the other side of the circle, then I did the radius twice, which is called the diameter. And so that's what's labeled there on the picture in my notes that I'm sharing with you. There's also right there underneath the definition of what a circle is, there's the equation of a circle. That's the x minus h quantity squared plus y minus k quantity squared equals r squared. That h and that k are your center. That's where that center point is. And that r is the radius value. The x and the y are actually the variables, and those stay x's and y's in terms of the equation as we work through it. But the h, the k, and the r all are actually numbers that we substitute in there. You would have seen this back in Math 30 if you took Math 30 here at Missouri Southern, or you would have seen this in I'm assuming you guys get to it in Algebra 1 in high schools, but I know high schools treat their algebra classes differently. You definitely would have talked about circles in geometry. You would have talked about circles in trigonometry. You would have talked about circles in Algebra 2. So they all definitely would have come up in those different classes. But we do talk about circles here, and we do solve our circles, and we graph our circles. So, like I said, the diameter is a line segment that connects two sides of a circle that goes through the center. That is important that it goes through the center, because you can have other lines that connect a side of the circle with a side of the circle, but don't actually go through the center. And those are not the diameter, and those are not really important to us in terms of this class right now. And like I said just a minute ago, the diameter is the same thing as 2 times the radius, because you walk from the edge of the circle to the center, that's the radius. You walk from the center to the edge of the circle on the other side, that's the radius. So you cover the radius twice. So that is the circle. I'm actually going to leave that up in case you are just looking off of my notes. And then I will do the example on the board in this little section that I have. I know you can see it and you can see the answer, but I'm going to still work it, because sometimes just looking at it doesn't click if you're an auditory learner or a visual learner and you actually like to see it moving and worked out. So the first example says, find the equation of a circle with a radius 5. So right there, I would make a note. We have a radius of 5 and we have a radius of 5 and the center of 3, -7. So we have center of 3, -7. And that's all we know, but we need to write the equation of a circle. Well, just up above the graph of the circle, or the picture of the circle on your notes, I gave you the equation of a circle. That's the x minus h squared plus y minus k squared equals r squared. That's what we're going at for this one. We want something that looks like that. Well, we know the r is 5, and our center, remember, is our h, comma, k. H, comma, k is still just an ordered pair. It just uses different labels because this one already has an x and a y. So we're going to use h and k. The nice thing about it is, once again, though, it is in alphabetical order. So your x value of your center goes with your h, and the y value of your center does go with your k. It's alphabetical. So now we just plug in those values. If I have x minus h, well, my h value is 3, quantity squared, plus y minus my k value. My k is negative, so we have a minus, a negative, which will give me a positive. And then r squared, well, 5 squared is 25. This is the equation of a circle with a radius of 5 through the center point 3, -7. Right here. And hopefully, if you were given just the equation like this, we could go backwards and we could say, okay, well, if I know that's the equation of a circle, then I can find out my radius. I would have to take the square root of this number, but that would give me the radius. And I could look here for my h and my k. The one thing to be wary of if you're going from the equation back up to the information, because that will happen, because sometimes they're going to give you this, they're going to give you just the equation, and they're going to say, now graph it. Well, how do you graph a circle? Well, to graph a circle, we have to plot the center and then use the radius in order to graph it. We're going to do that at the end of this lesson. But in order to find that center, we have to look at this equation. Now, here's where you have to be a little bit careful, because you have to think about what the original equation looks like. The original equation has a minus inside of these parentheses. So if I'm looking here and it says -3, I need to remember that that doesn't tell me that my x value for my center is -3. My x value for my center is actually +3. And that's because the original equation has a minus in there. So if there's still a minus in there, then the x value is going to be positive. Whereas over here, because my y value, my k, was negative, that became a negative, which gave me a positive here. So they're kind of backwards from what you would think. And I see that happen a lot, where students will flip-flop the signs on those, which then means that instead of graphing their circle up here, they end up graphing their circle down here, and it makes it incorrect. So do be careful on that if you do go from the circle equation up to finding the center and the radius. And like I said, we are going to do a couple of those in just a minute. So you'll see that played out. Let me move back on full screen. And let's look at the next style of problem that we are going to do. We are going to use two different ordered pairs. And we're going to pretend that those are the endpoints of the diameter of a circle. And then we're going to find the center of that circle. And we're going to find the radius length for that circle. This is where we are actually utilizing the information that we just talked about in terms of distance and midpoint. Because if I have a circle and I have my diameter that runs through my circle just like this, then look at this. My center is what? My center is actually the midpoint of my diameter. So center is midpoint of my diameter. That's good to note, because then if we are being asked to find the center of the line segment that actually is the diameter, then we're just finding the midpoint. So center is the midpoint of the diameter. And then if we need to find the radius length, then what we're doing is we're actually just finding the distance from the center to one of the points over here. And it gives us the points. It tells us the points are -11, -1, and 3,7. So pretend, I mean, obviously this isn't accurate, but if we pretended like this was the point -11, -1, and this is the point over here of 3,7, which is what they gave us, then what we need to do is we need to find the midpoint so that we combine the center. And then from there, we just find from the center to one of these outside points, and that'll give me my radius length. So we need to find the center first. That's what A is. A asks us for the center. And as we just said, the center is the same thing as the midpoint, since they gave us the endpoints of the diameter. So midpoint was x1 plus x2 over 2, comma, y1 plus y2 over 2. So my x1 was -11 plus my x2 which was 3 all over 2, comma, y1, which was -1, plus y2, which was +7 all over 2. So -11 plus 3 would give me a -8 over 2, comma, -1 plus 7 would give me a +6 over 2. Simplifying that would give me a -4, 3. -4, 3 will be the midpoint of the line segment from -11, -1 to 3, 7. But since we specified that that line segment is a diameter, then that midpoint is actually the center. So this is the center of my circle. So that was part 1. We found our center. Part 2 or part B says we need to find the radius length. We need to know what the length of the radius is. Well, if we use the, sorry, let me angle it out a little bit. If we use the 2 ordered pairs that they originally gave us, we would find the diameter length. And that is totally fine. We can do that. But if we find the diameter length, then we have to remember that diameter equals 2r. So we're going to have to divide that by 2 at the very end. And that's actually what I do. I use the diameter and I don't use the center. You could use the center as one of your endpoints, as like your x1 or your x2, and use one of the outside points. The only thing that could go wrong if you use the center as one of your points in terms of finding the distance here is what if you found the wrong center? What if somewhere in here you did an algebra error and you got the wrong center and then you took the distance from there, then you're going to get the wrong distance again. So it is a little bit safer to use the 2 points that they give you and then just divide it in the end. Because remember, diameter is 2 times r. So if the diameter is 2 times r and the distance of the diameter is what we're going to find, that's okay. We can do that. We just at the very end divide whatever our diameter distance is by 2. So distance equals, I'm going to write it out because I'm using it and I'm going to use it every single, every time I use it, I'm going to write it down. That's x2 minus x1 squared plus y2 minus y1 squared. So write it down. And then we plug in the values. My x2, I'm just going to go in the way that I wrote it on the board here, which I'm trying to zoom out from. Like that. So I'm going to say that this is 0.1 and this is 0.2. So my x2 would be 3 minus my x1, which was -11, which becomes positive, plus my y2 would be 7 minus, again, my y1 is a negative, so that becomes a positive. So in here I have 3 plus 11 is 14 squared plus 7 plus 1 is 8 squared. 14 squared, get a nice calculator out, 196 plus 8 times 8 is 64. So I get the square root of 260. Now, you wouldn't know this because I didn't write down all of the instructions on here, but it does say that I'm allowed to round to the nearest hundredths place. So I'm going to actually use a calculator to find out what is the square root of 260. Well, the square root of 260 is approximately, if you look at my notes, then I use the curly equals. That means approximately. That means I did some rounding. So approximately 16.12. Now that 16.12 is the distance of the diameter. Now remember, diameter is twice the radius. So I have to divide that 16.12 by 2 in order to actually get the radial distance. So that means that I have 8.06 is approximately my radius. And all of that is in my notes. I know I was blocking it, but it is all right up there. Worked out the exact same way. So maybe you're one that you like to draw a picture every time and it helps it to sink into your brain a little bit. Totally fine. Maybe you don't need to write it, and maybe you already know the midpoint formula and the distance formula and you don't want to write those down every time. That's fine. I'm a big proponent of you do as much as you need to do. But if I come through and you're asking for help and you don't write down the distance formula and then you do something that with the distance formula that's wrong, and you do a math that's wrong, but you're not showing me enough math, then I might ask you to show a little bit more just so I can help you through it, because I want to know where it is you're actually going wrong so that I can make that correction before it becomes like a big problem later on down the road. But that is how we find the center given the diameter endpoints and how we find the radial length. The next example that we're going to do is we need to find the equation of a circle with the diameter whose endpoints are -4, 3 and -5, 2. So in this case, we need to get the equation of a circle. We're not necessarily, we're gonna have to still find a lot of this stuff, but that's not exactly what they're asking for. What they want is they want that, let me erase this part right here. They want x minus h squared plus y minus k squared equals r squared. They want this. They're asking for the equation of a circle, and that is what they're wanting. Now, all they give us are those two endpoints again. So I'm going to write them up here. I'm going to leave our same picture. So we have -4, 3, and we have -5, 2. Those are our endpoints, and yes, those are probably backwards based on how I drew the picture, but that's okay. So we have the endpoints. They didn't give us the center. They didn't give us the radius. They didn't give us any of that information, and we need that information because our center is HK and our radius is here. So we have to have that information in order to give the equation. So really, we're doing the same problem again. It's just they asked it in a different way. Instead of us just ending with our ordered pair for our center and ending with our value for our radius, we're going to write it as an equation. But we're still going to have to do the two parts. We got to find our center. We got to find our radius. So I'm just going to erase the stuff here and use kind of the same outline. Because if we have the two endpoints of our diameter again, then to find the center, I've got to find the midpoint. So x1, let's say that's -4 plus x2, which is -5 all over 2, y1, which is 3, plus y2, which is 2 all over 2, and we get -4 minus 5, which is -9 over 2, and 5 over 2. So you might be like, well, that's kind of gross. It is, but this is algebra. Algebra, you have to be confident and comfortable with fractions. They're going to keep coming up. We have to know how to add, subtract, multiply, and divide them. We have to be okay with these. If you had me in 20 or 30, you know, I harp on that a lot. Because sometimes students see fractions and they just immediately shut down. And we have to be able to overcome that fear and insecurity when it comes to fractions so that we can actually master the algebra. So even though you're like, well, that's kind of a gross answer, this is the center of the circle with that diameter. So we're going to leave it because that is okay. Now we're going to find the distance. So distance x2 -5 minus x1, which is a -4, so that becomes positive, plus y2, which is 2, minus y1, which is 3, which becomes positive. So this becomes a -1 squared plus a -1 squared, which is 1 plus 1, which is square root 2. Now, remember, this value here, though, that we just found is the distance of the diameter. So the radius, we have to divide that by 2. So our radius is actually the square root of 2 all over 2. And you're like, well, that's gross. I'm sorry. That's how this problem plays out. But now we have our radius, which is the square root of 2 over 2. We have our center, which is our HK. So we're just going to put those values into the basic format of our circle equation, where we have x minus h. Well, we have a minus, that becomes plus 9/2 quantity squared, plus y minus k, which is 5/2 squared, equals, I am going to erase this hk just because it's getting in the way. Then what's our r? Well, we said our r was radical 2 over 2 squared. Now, we don't want to leave our r squared like this. We want to actually compute that. So over here on the side, I'm going to put square root 2 over 2 times square root 2 over 2. So square root 2 times square root 2 gives me square root 4 over 4. Now, what is the square root of 4? Well, the square root of 4 is 2. So it gives me 2 over 4, which simplifies down into 1/2. So the square root of 2 over 2, quantity squared, is actually the same thing as a half. So that means my final equation for the circle is x plus 9/2 squared plus y minus 5/2 squared equals 1/2. This is the equation of the circle whose diameter has endpoints at -4, 3 and at -5, 2. I will say in general, I try to find ones that are slightly quote unquote nicer in terms of the numbers to where it would have whole numbers. But I did specifically do this problem in the notes and here in the lecture because I want you to see that they don't necessarily have to have quote unquote nice numbers. They could have fractions, they could have radicals, and you should be able to handle those. Just trying to move that out of the way. Being a college algebra student at this point. Another thing though that I want you to notice for a second is look at how much stuff I have written on this board versus how much stuff I have written in my notes right here. Because I know how to do midpoint and I know how to do distance and I understand what I'm plugging it into, and I can do this squaring part all in my head. And if you are one that can do some of it in your head and you don't need to write it all out, like I said, feel free to write as much or as little as you actually need to be successful in this course. All right, we're going to do one more. And then I'm going to show you how we graph some circles, and then that's actually the end of this lesson. All right. So it's find the equation of a circle. So we're still going to find the equation of a circle with the center at -5, 4. Ooh, so they were nice. They even give us the center this time. So with the center of -5, 4 tangent to the y-axis. So tangent, if you ever see that, which you 100% will, if you decide to go on in your mathematical career and do any calculus classes, tangent lines are very common because that's how we're talking about limits later on. So get comfortable with those. But if you are tangent to the y-axis, and what that means is you are touching at exactly 1 point, just one. You're not touching anywhere else. So if you are touching at 1 point on the y-axis, then we can kind of think about, pretend like if this is drawn, this circle that I've kind of been playing around with, like this. But pretend like this dot right here lies right on that y-axis. That's what being tangent to means. It shares one point with the y-axis. Now, how does that help us? Well, it told us our center. Our center is -5, 4. Like that. That's what we know. And if we know that the circle is going to share one point with the y-axis, then this is actually enough information to tell us the radius of the circle. Because here's what I'm going to talk about. If we're at the center right here of -5, 4, and I need to walk over here to touch the y-axis, how far do I go? If I have to start from the center and I walk till I touch the y-axis, then how far do I go? I'm going to go 5 units because my x, which I know this is really wonky, I should have drawn it on the other side because my x is negative, but what happens is I still have to cover my x distance to get over to my y-axis. Let me switch this just because I can. Let me switch it over on this side. Like this. So if I go 1 unit, 2 unit, 3 unit, 4 unit, 5 units, then I'm back here at the y-axis. Do you see that? I hope you guys see that, because they've really given us everything we needed to know in that one little short section by giving us the center and telling us that we are tangent to the y-axis. Because being tangent to the y-axis means that my radius is actually 5 units. So now I have my radius and I have my center, so I can have the equation of my circle. Because it's x minus my h, well, my h is negative, so it becomes a positive quantity squared, plus y minus my k, which is 4 quantity squared, equals my radius squared. Well, my radius we determined is 5. 5 squared is 25. So do note that if you are tangent to something, that means you touch it with just one spot. And there's a little bit more of the information. The radius is 5 because the center is 5 units away from the y-axis. So do be a little bit careful because that could seem a little weird that we are tangent to the y-axis, but our radius is actually dealing with our x's. That it's because we have to move in the x direction to touch the y-axis. These problems could be very similar to this, only we could be tangent to the x-axis. And then we have to think about walking up or down in order to get to our x. And so then we're going to be looking at our y values. Okay, so let's finally graph some of these circles. I told you that in order to graph a circle, you're going to need to know your center and your radius. And luckily, I think most of your problems are going to give you the equation of a circle. And if you have the equation of a circle, you have the center and you have the radius. And so you're going to be good to go. I was going to leave that up there, but I think I can leave most of that problem above up there and still give you the equations. So the first equation that we are graphing is an x squared plus y squared equals 9. On your My Math Lab, like when you go to graph a line, there's a line tool that allows you to graph with a line. There's also a circle tool that allows you to graph with a circle. And the way that you use that is you click on that circle tool, and then you're going to plot your center first, and then you're going to drag your circle out until it's as big as you need it, determined by your radius length. And that's kind of what we do here when it comes to graphing with a circle. So first thing I'm going to do is I'm going to look at this and I say I have an x squared plus a y squared equals 9. Now I know that an equation of a circle is supposed to look like x minus h squared plus y minus k squared equals r squared. But if I look at this, I don't have an h, I don't have a k. Well, that could be a problem. But then you have to think a little bit further and think, okay, well, is there an H there and it's just, not represented because of what value it is? And the answer is yes. Because here's what I would say. If I said I have an equation that looks like A plus B equals C, but I only have 7 equals C, and I need to know what A is, well, either 7 needs to be split, but I'm going to tell you that can't happen. So 7 is actually the value of B. So then what is the value of A? Well, I don't know because there's nothing written there, right? But what if I told you you could write 0 there, where you have 0 plus 7 equals C, to where A is actually 0. We just don't usually write it because it takes up space. And in algebra, we like to keep things as nice and neat as possible. That's actually what's happening over here with this problem. This is the circle equation. It's just that our x for our center is 0. We would have x minus 0 squared plus y minus 0 squared equals 9. But this looks a lot yuppier. Yes, that is a true mathematical term, yuppier. This looks a lot yuppier than this. And so that's why we write it like this. So if you see x squared plus y squared, you should hopefully start to immediately recognize that as telling you that you have a center then at the origin at 0, 0. So x squared plus y squared equals 9 has a center at 0, 0, and my radius, well, is r squared. 9 is r squared. 9 is r squared. To get rid of that square, you would square root. So 3 is my radius. So we have our graph. We go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now, I'll go ahead and warn you, most of my graphs, because I just freehand it like that, my circles look a little bit more like footballs, but I'm okay with that. So like I said, in order to graph a circle, first thing you do is you graph your center. Center is at 0, 0. So I plot that first. And then I'm going to use my radius to make a couple more points around my circle so I can draw my circle. So if my radius is 3, that means you start at your center and you're going to go up 3. You're going to go down 3 from your center. You're going to go to the right 3. And you're going to go to the left 3. And then I'm going to connect. Hey, that's a pretty good circle-ish. And then I connect those, and there's the picture of my circle. It has a center at the origin of 0, 0, and it has a radius of 3. So let's look at our second one. So for B, we have x squared plus y plus 2 quantity squared equals 2. So this one, we do have this y plus a k value over here. But over here, again, we don't have that h value, which should tell you automatically that your h then is going to have a value of 0. So we could write this as x minus 0 quantity squared plus, and then we'd have y. And I'm actually going to do something here because I want you to be able to pick out the value pretty quickly. Remember, the original equation has a minus. So I'm going to write minus. And I know it says plus. So how do I change a plus into a minus into a plus? Well, I have to have another minus, which tells me that my k value is actually a negative. That's why I wanted to write it like this, so that you can see that. Because now when I ask for the center, which is the hk, hopefully you say, well, my h is 0, and my k is -2. Now, do you have to write this step, or can you not just look at this and go from there? Absolutely. I'm going to show a little bit more. One, because it's a lecture video and I'm not under a time constraint on how long I can lecture. And so usually my lecture videos are longer than my actual in-class lectures because I can spend more time diving into things that like this, where in class I would just say, okay, well, my H is 0. And since that's positive, that tells me my K has to be negative, you know. But I like to go in a little deeper if I possibly can when we do this. And then I feel like there's a typo. I'm going to say there's a typo in my notes here, and that this is supposed to be 4. Just going off my graph, I think that's supposed to be a 4, and that my radius then would be 2. See, finding all kinds of mistakes. So that's supposed to be a 4. That way we have a radius of 2, which then matches the graph that I have drawn on here. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I have no idea if that's how many I need. Just ballparking it. So again, we start with the center. The center we found was 0, -2. So we use 0 on our x's, down -2. And then from there, we're going to use our radius, which was 2. We're going to go up, down, left, and right. So we go up 2, there's a point. We go to the right 2, there's a point. Go down 2, there's a point. And we go to the left 2, there's a point. This one's definitely more oblonged. But that's okay, because when you're using my math lab, it makes a nice perfect circle for you every time, which is lovely. And that's how you're going to graph using the equations of a circle. And that is actually the end of our introduction into graphing. And that's the end of our first lecture.